Welcome to this tutorial on thinkingParticles 7.3 Service Pack 4. Showcasing one of our many shipping sample scenes, the scene we are going to explore is called TP Cloud Generator, crafted by our beta tester Marc Auvigne. This scene empowers you to generate limitless cloud VDB files. These volumetric data files, an industry standard, seamlessly integrate into various 3D applications, renderers, and workflows. In this tutorial, we'll explore how to create individualized cloud volumes using thinkingParticles version 7.3 Service Pack 4, along with finalRender for output. Why spend a single dime on cloud VDB files? Just create your own. Let's get started. Let's load the sample scene. You might already know that thinkingParticles ships with a lot of sample scenes. In fact, we're shipping more than 430 sample scenes with a standard installation of thinkingParticles. And those scenes are really valuable. They are a treasure trove of functions and features and visual effects you can just load, analyze, learn from them, and even use them as your base for the next project you might have to do. So in this sample scene, let me just tell you a little bit about the sample scene, because it's a really special scene, and this scene was supplied by one of our beta testers, Marc Auvigne, and we are very thankful that he's willing to share the scene. And that's actually a nice thing about the thinkingParticles community. People are helping each other and sharing a lot of knowledge about thinkingParticles. So in this scene, you can not only learn how to use VDB files, how to generate VDB files and create, for example, clouds. You can actually use this to create an unlimited amount of clouds or cloud files, VDB files. And those files can be used with 3D Studio Max, or they can be used as well with any other application out there on the market, because OpenVDB is an industry standard to save and transport volumetric data. But let's have a look now in 3D Studio Max what we did here and how this system from Marc works. So the first thing here is our default layer, where we can find some lights and cameras. And the next one, let me just go there. The cam is not used right now in this scene. We have our cloud geometry. Let me just activate that cloud geometry. Sorry, here we go. And there we have it. That's our little rabbit here. And we will use this rabbit throughout the tutorial to create our cloud or test our cloud generation. Then we obviously have a layer where we can find our lights, and we have a layer where we can find our thinkingParticles related stuff. So let's dive right into the setup Marc did for the thinkingParticles cloud generator. And I'll bring it over in a second, and let me warn you, it's quite a thing Marc did here. So what we can see is we have pretty nice organized set of particle groups. So we have the original shape particle group, a cloud shaped, and a new cloud merge particle group. I'll tell you what these particle groups are doing and why we want to use them in that way. And here comes the dynamic sets. So don't be shocked at first if you're a new user. It looks complex. There's a lot of nodes Marc used to generate this cloud generator, but we'll go through step by step and you will see it's not that complicated, especially if you only want to use it to generate clouds for your project or just to have some volumetric clouds in your scene. It's very easy and simple to use because Marc prepared this file so that it is flexible and usable for all kinds of situations. Let's start with the acquire original geometries. So what Marc used here is our layer to particle node. So what does this node do? The layer to particle node allows you to use wildcards. So you can just use a wildcard and gather information from the 3D Studio Max world. In this case, he is collecting all layers named cloud. And there's only one cloud layer right now that's called cloud geometry. And in that layer, we have our rabbit in there. As you remember, I showed you the rabbit 3D mesh. The next thing is when we pick the layer here, we grab now all the objects in that layer. And that means we need to be a little bit careful, especially with volumetric data that can really explode really fast. So what we get here in the next wildcard is get me all objects. And right now we only have one object in there. And I will show you how great and flexible this system is, because whatever we throw onto the cloud layer, that will be turned into a cloud. So that's a very flexible system to use here. The next dynamic set is doing some computation, and you might want to dive into it. I'll just roughly explain what's going on. So when a particle is born, so we get from our cloud layer our mesh into thinkingParticles, so the rabbit. So whenever a particle is born, we use the particle node, the condition. Whenever it's born, something happens. So it only happens one time. Whenever a new object appears, all the rest down here is activated. And what it's doing is basically it grabs the information of the mesh, accesses geometric data, and especially the data we're interested in here for our purpose is the size of the object, so that we know how large the object is. And then we grab this size of the object and just pick the maximum X, Y, and maximum of Z. So we know the max values of all its dimensions. And we store this information in a data channel called Vsize. So this is stored in the Vsize data channel, so we know how large or how big our object is. So that's all about this, or for this setup. And the next setup we're going to do is, oh, and by the way, we have this float operator here where we can adjust on the fly the size if we wanted to. So it's set to multiply right now. It's multiplied by 1%. So that's assuming just 1% of its original size. Okay, we have done that. That's getting our rabbit or geometry in and calculate a size for our voxels. We want to voxelize the space or volume of the mesh. The next thing we're going to do here is, let me just collapse all these nice dynamic sets here. So the first thing is the container, and that should be container. Oops, my typo, container. And the container is our OpenVDB node. What this does is the OpenVDB node creates or prepares for a volumetric data object. And what we want to have here is a distance field, a signed distance field, and 2 fog fields, and another distance field. Marc is doing some calculations that are pretty advanced, and he uses them to generate a natural looking cloud, but still respecting the shape of the object you put in. So that's basically it. This OpenVDB is just a container. It prepares, it doesn't create any volume. It just says or prepares the system to allocate space for memory for a distance field, fog1, distance 1. The next one is our first step in actually creating volumetric data. And we have a lot of OpenVDB nodes. And by the way, the OpenVDB implementation in thinkingParticles is the best on the market. There's really nothing that compares to it. We have a very unique approach to volumetric OpenVDB files and how to handle them. For us, an OpenVDB file is just a particle, like we use our philosophy with 3D Studio Max meshes, where we turn everything into a particle. We also turn volumetrics into particles. So a particle holds all the data and can be manipulated. So we can size and align the particle, and it will automatically size the volumetric effect and align the volumetric effect. So there's a lot of things. And also we can kill the volumetric effect like we can kill a particle. So when the particle dies, the volumetric effect is gone as well. That's a very unique approach. So what we have here is we grab our original shape we got from our layer to particle. So we grab our rabbit here and we stored in the previous dynamic set the voxel size here. And with the voxel size, we grab this voxel size with a percentage. Right now we take the same amount and set it in shape to volume. So what shape to volume does is it creates a distance field. So we turn on a distance field, and it also at the same time can create a fog field as well. So now we create out of this particle, which is our rabbit, our geometry, we create a volumetric representation of this rabbit. And the resolution right now is set to this value, 0.5. This is just an intermediate process that is used here, and there's several options. We can also use the original, we can use our new cloud method, or a combination of that. But more of that I will explain later on. The next thing, let's move on to our generate cloud shape. So in the generate cloud shape, we have a lot of things going on. Just close that here. So in the generate cloud shape, we have some controls. The nice thing is Marc flagged all the important stuff with controls, with these notice boxes or note boxes. So we know, okay, here we want to change something. So we can control the sphere density, and we can control the type of cloud we want to create or volumetric data we want to create. And if we set this to 0, we use only the sphere type. If we set it to 1, we use the original shape only. And if we set it to 2, we use both. And that's really flexible. I haven't seen any other system offering these options. They usually have only one option to generate a cloud, a volumetric cloud of your actual 3D geometry. So here are controls we can adjust anytime we want that will generate our output. Now let's go to the cloud shape type. Let me just open up the cloud shape type here. And that's the logic behind what I just mentioned. If you want to have the shape only, the sphere only, or both. And that's just the logic how to switch and flag which option you want to have for your volumetric data. The next one is the generate sphere clouds. So that means what he's doing here is he's using an OpenVDB node that will do packing, or will use a packing algorithm, and that will pack the volume with spheres. and we can have a minimum count, a maximum count, size, min size, max size, and so on. But what it does is it creates spheres inside of our volume, and these spheres are assigned actual geometry. It's a standard geosphere in 3D Studio Max. So all these positions with sizes are also randomized as well. So it gets a random scale. And we have the geometry here. So now we fill our volume with spheres. That's done. And the next one is we are creating a snapshot of all the spheres to create one particle. And then here we have the snapshot of that. And we go and move on to creating our own new cloud particle or volume in this step. So again, Marc flagged this with notice here. And he also explains that we might need to increase our exterior bandwidth when we start playing around with values here. Here's one important control you might want to check out. That's the actual resolution our cloud will have, how fine the detail is or how fine the noise will be represented within the voxels of the volume. So that float here controls our quality or detail of our final cloud. So let's move on to the last important dynamic set, and that's the create noise dynamic set. This dynamic set will control how your cloud looks like. If we were to play around a little bit with the size, let me just move that scale a little bit smaller, and we'll go to frame 1. We can see that's how the system looks like. When I play around with the size of the noise, let me just make that a little bit bigger. Let's say 5, for example. It's now calculating and it changed the size. Let me just overdo it a little bit. Let's go to 50, and then we will see the size totally changes of our cloud. And opposite, if I make the size of our noise smaller, we get more intricate, smaller details in our cloud. So, but for now, I'll just keep it at 3, and we'll have our cloud at 3. The same is for the fine detail noise. If we increase the fine detail noise, we won't see any curls or fine details here at the edges. And if I decrease it, let's say to 0.9, we will see more intricate details at the edges. So it's a really nice setup Marc did here. And let me just show you how the rendering looks like. Let's just render this setup here, and here we go. We have our rendering. Now let's play around a little bit with all the details we can get and create, for example. So let's say we want to play around with the size or intensity multiplier, for example. So let me just close this view again. When we now decrease or increase our displacement here, which is a little bit of a critical, let me just go one more step. And then if we start to render that, we will see how our clouds are looking. And obviously, we can also control how dense we want to create our cloud. Let me just go here and have the density multiplier. So let's make it really extreme. I'll put that to 40, and we will see already here in the viewport, it will be a really dense cloud. So now we are entering a range where we create foam-like structures or foamy-like structures, but still if we fine tune a little bit more, we can create really interesting looking clouds. So let me just dial this back to our value of 3 and let me show you something that really explains why this is really a flexible system. Let's, for example, let's have some fun and model our own cloud. So we don't want to use the rabbit anymore. So just for reference, I'll keep the rabbit there so that we are kind of in the same scale and position for our camera. I'm going to use boxes here, and I will just rotate them randomly somehow and do something like this, and also randomly rotate the box like this. And maybe we're adventurous and we'll just add another box. Let me just copy that box here, and we're going to just rotate the box something like that. And I'll move that probably a little bit further, something like that. And let's just look here. Yeah, that looks good. And now, how about we add some rounded corners where we just use a chamfer because we're all lazy. Let's do that. Give it some segments, and I'll assign it to all my other boxes as well. Here we go. Little box. Everything is chamfered. Let's add a Boolean and pick the other boxes and merge them all into one object. So that's it. That's our, so to say. Let me go back to frame 0 and we'll just move the rabbit out of our cloud layer, and I'll bring into the cloud layer. That's all we need to do. I brought in the box now into my cloud layer. And now, let me just hide that. When we go and start the simulation and calculate our cloud object, here we go, there's our cloud. So what you saw is it is so easy with this scene to actually create or generate an output for you. So you can create as many VDB clouds as you want. There's no need that you spend a dime on a cloud file. You can create your own, you can model your own clouds. And there's no restriction at all. We can use, for example, a text and turn a text into a cloud. As I mentioned, it doesn't matter. It's just geometry. We fill that geometry, and the setup Marc did here is really working good. It's really amazing. Let me just bring that in and give it a little bit of an extrusion so that we have actually a volume. And we want to rotate this little thing into our camera. So here we go. There's our TP. Let me just have this up here, maybe something like that. And we'll move it over here. Maybe move it a little bit more over here, something like that. And there we go. Something like that. And now the only thing I need to do is the same as I did before. Let me just go back to frame 0. I'll move this into the cloud layer. Because the scene is set up like that, it will automatically grab the mesh, calculate its voxels, everything it needs, and it will create a volume effect, a cloud out of our TP logo. Or letters writing TP into the sky. So now let's have a look at this setup. So, and again, you're flexible. You can create as many clouds as you want, any style, any resolution, any detail you want to have. So if we wanted to have them more fluffy, more translucent, that's also no problem. That's just a matter of the shader. And as I mentioned, these VDB files, they can be used with any renderer, with any 3D application. So you can create VDB files for Houdini, you can create VDB files for Cinema 4D, for Maya, any application out there that can read VDB files and render them. Now I opened the material editor, and Marc is using for generating the clouds the OSL shader, the organic noise shader, to create the cloud noise or structures. But what I wanted to show you is just our finalRender. I'm using finalRender, and we're using Nano VDB for rendering. So it's a really fast GPU accelerated rendering. So now let me just decrease the density. Let's say 0.5. Let's do a rendering, just to get more light through the cloud. So I don't want to have these bad weather clouds. So I just want to have them more transparent, more transport of light. And probably I want to have it even more transparent. And as you can see, it's just seconds, mere seconds, where we calculate these clouds. And now we have our fluffy cloud here. So that is just one sample file I showed you that we are shipping of more than 430 sample files. So keep in mind, there's a lot of treasure waiting for you to just load it in and explore it. And the files can be found. The files can be found in the standard 3ds Max documents in your documents folder, 3ds Max versions, scenes, thinkingParticles, TP 7.3, Service Pack 4, or all the other files as well. When we go up one example, we have, as I mentioned, a huge amount of sample scenes, starting at release 6 up to 7.3, Service Pack 4. Those are the scenes we are using here. And I will have another tutorial explaining the unfolding scene file that Marc offered or gave us as well. So there's a lot of things to explore for us, and I hope you enjoyed this video. Have fun making clouds, and thank you so much. Goodbye.